Hello guys, welcome back. In previous video, we explained the backbone of data analysis. Today, we're going to cover the single most important step in any data analysis or machine learning project, which is data cleaning. In real industry settings, professionals spend around 60 to 80% of their total time cleaning data. Why? Because every business insights, every machine learning model, and every KPI dashboard depends on one single thing: the quality of your data foundation. So, in this session, we will walk through how professionals build a reproducible, audit-ready data cleaning pipeline using a real dataset, the Online Retail Dataset, commonly used for customer and sales analytics, especially for Know Your Customer or KYC analysis. Let's begin. Before jumping into code, let's first understand the architecture of industrial-grade data cleaning. Think of it as a 6-step framework, the backbone of all reliable data cleaning work. First, handling duplicates. The goal of handling duplicates is to ensure each observation is unique. Then, dealing with missing values. This addresses gaps in the data without introducing bias. Correcting data types ensures consistency in numerical, text, and data time fields. Cleaning text data. The goal of this is to standardize and normalize textual entries. Handling outliers to manage extreme values responsibly. The last but most important, documentation. This is for final check and comprehensive documenting for all cleaning steps for future reference and compliance. This architecture is what separates professional data cleaning pipelines from ad hoc one-time scripts. Let's move into Python and begin. First of all, we always need to import the libraries and load the dataset. Here, I already said import pandas. We still use pandas read CSV function to read the online retail.csv. Notice that we specify the encoding here. This is basically to avoid issues with special characters in products or countries. And always make sure to make a copy of your original data so that you can validate and trace every transformation later. Then, as usual, we inspect. First, we inspect the df.head to see if this data is loaded correctly. Also, we want to know the basic info of this data. We see there are a total of 8 columns, which means we have total 8 features for this data frame. Description, it might have some missing values. Customer ID, it also might have some missing values. We also see that invoice date here. Object dtype, which is obviously suspicious for a date variable. Then we see the statistical summary of this data frame, which is my favorite part as I mentioned before. Immediately, we can see there are suspicious negative number for quantity and unit price. This quick EDA reviews your data's types, missing columns, and numerical distributions, the foundation for all decisions that follow. Then we move to the data cleaning part. First, we deal with duplicates. Duplicate rows are surprisingly common in transactional systems. Let's check and remove them. We see there are more than 5,000 duplicates. We remove duplicates with drop duplicates function and we check it again. All duplicates are removed. Defining duplicates is not purely technical. It's more like a business logic. In retail, 2 identical records of the same item, quantity, and time step usually mean an accidental re-entry. Now, missing values. First, we check if there are any missing values here. As we investigated before, we have missing values in description and customer ID. Customer ID are actually crucial for KYC and RFM analysis. So instead of just deleting them, we segregate. We create an extra data frame called dfkyc. In this data frame, we drop all customer ID, and we deal with the missing value with another strategy, which is called imputation. For this, instead of just deleting them, we fill those missing values in customer ID with unknown cost. The next step is to impute description. Here, we fill the missing values in description use unknown product. And we check. Now all missing values are fixed. The next step is to enforce logical consistency, where business meets data. Quantities and prices must be positive. Negative quantities often mean returns, so we separate them out. The techniques applied here is called Boolean indexing. Now for date-time conversion. This is essential for any time series analysis. Here, we just need to use toDateTime to convert the data type. See, invoice date is now converted to datetime. This enables monthly trends, seasonality studies, and customer recency matrix. Without it, your time-based analysis simply won't work. Now we move to the feature engineering phase. We need a dedicated country column for analysis. And we need a key matrix, which is revenue. For the country field, we first apply text cleaning techniques. We begin by checking all the unique country names. From the output, we can observe several problematic entries. For example, some outdated or non-standard country names that are no longer commonly used. To address these issues, we create a mapping dictionary that defines how each inconsistent country names should be corrected. We then apply this dictionary to the country column to standardize all entries. You can now see all the problematic entries are fixed now. Once the country names are standardized, we can derive the most fundamental financial metric for sales analysis, which is revenue. We create a revenue column by multiplying quantity and unit price. This is a form of feature engineering. It's often done during or right after data cleaning. Next, outliers. Outliers can distort averages and model performance. In business, not every large number is wrong, but every large number needs justification. We will use the interquartile range method to define an upper threshold. We filter the dataset to remove the most extreme high-quantity outliers, which is above the upper bound. We can see the upper bound is 26. And we apply Boolean indexing again. This prevents extreme orders, whether accidental or wholesale, from skewing your results. We also validate one last time. This is to confirm there is no missing values, all the types are correct, and to check the final row count. You can see now there are total 9 columns with one extra column called revenue, which we created in our feature engineering phase. The cleaned dataset is now reliable, consistent, and ready for business analytics. We can save this cleaned dataset into a new CSV file called Online Retail Cleaned. This file can be used for the next stages, such as analysis, modeling, and dashboarding. But more importantly, this process is documented, reproducible, and aligned with real-world business logic. Let's summarize the key principles. As you might notice, context is actually the key. Industrial-level cleaning is not purely a technical task. Every decision must be justified by the business goal of the analysis. Second, segregation could be a better choice. For critical columns like customer ID, it's often better to segregate the data, like create a separate data frame, a data frame called DF KYC, and a DF, rather than just deleting useful revenue data. Third, validation is crucial. Steps like checking for quantity is larger than 1 and unit price is larger than 0 are actually business logic checks. These are the most common source of error in real-world analysis if overlooked. And last, documentation is a must. In a professional setting, the cleaning script and its relational must be thoroughly documented for auditability and reproducibility. This is how industrial-grade data cleaning transforms raw data into business-ready insight. So we started with messy, inconsistent raw data and ended with a clean, validated dataset that's not only analysis-ready, but also business trustworthy. In the next videos, we will dive deeper into the analytics phase, specifically applying RMF analysis, the industrial standard for Know Your Customer projects in retail and e-commerce. If you found this helpful, please give this video a like so more people can discover it. And if you're new here, subscribe to stay updated on more data science. What's the most frustrating part of data cleaning for you so far? Drop it in the comments. I read every one of them. I will see you in the next one.